So I showed this off a little bit on Saturday night, and we're going to go through some of how it works tonight, how I've got it optimized, um, what its limitations are, because there are some limitations with it, and then we're going to try and get some sprites in there, some raster rewrite buffer sprites. Thanks for the resub, Sean. Appreciated. Right, let me. Sorry, I just need to open an Internet Explorer. I know it's weird. It's just the only thing that fits nice and neatly in this gap at the side for my chat. Uh, so disorganized now because I had to restart. There we go. Need that on there. Okay, we're good. All right. You got resub. All right, let me start the quiz for those who want the quiz, and then I'll crack on with describing what we're up to. So racing quiz is starting now. Good luck, everybody, with that. Okay, so what I've been doing is writing what I'm hoping is going to be quite a flexible engine. I've had to inflict some kind of restrictions on it, just because of the way that the Mega65 works and the stuff I'm trying to do with it. But I've been documenting it quite heavily in this file here, which is the main config file. Puzznick, that was a great game. And trying to keep it to a minimum number of files. So at the moment, there's just a single file to import, which is this layers file. This layers file deals with all the macros and stuff we need to generate the code, the most efficient code for whatever your configuration is. So it's based off your config. So the code will be different if you change your config around, depending on how many layers you have and such. It's pretty simple, the config. You define a few base attributes here. So basically how many columns and how many rows your screen is made out of, where your screen lives in memory, where your map lives in memory, where the tiles are in memory, and where your first character is in the character set, because it's a 16-bit character set. So it runs from 0 all the way up to 4,000, I think, is the highest one you can have. I might be wrong on that. It might be 3,000. Also, I'm drinking cider tonight. I haven't taken the wine off the list, so it's just the cider on there tonight. So once you've got these base variables set, we've got a couple of layers that we can create, and so you can create as many layers as you want. All that will happen is that when you run out of processing power, the screen will display incorrectly, and I'll show you that a little bit in a minute when we go through the limitations of this. You import each layer as a binary output from Sprite. I've got a JavaScript file which generates these binary files, so you don't really need to think too much about how these are set up, but I will go into some of this as we go through. And that's it for layers. The only difference is the sprite layer. So a sprite layer, it's kind of like the other layers in that it's created in pretty much the same way, but its purpose is very different. So I'll go through what those layers are and how they look shortly. And then for each layer, you can set some properties. So you can set how wide the actual map data is in tiles, how high it is, what the actual display width of this is. So we just go one tile wider than the screen, so we can do some scrolling. The scroll factor is how much this layer will scroll in comparison to the control layer. Control is you can set the controller on a layer, and basically when you move that layer, all the other layers are adjusted according to that one. So what we do is we set the control on the foreground here, and then whenever I move this one, all these tiles move, all these layers move in a ratio to this one here. So the first midground area here moves at half the speed, so 1/2, then 1/3, and then 1/4, and so on. And this background is static; it doesn't move at all. So that's the sky really far in the background, doesn't move at all, and the HUD doesn't move at all here. There's a few other things in here as well, like wrap-x, which just makes sure that if you reach the edge of a map section, it will just go back to the beginning and draw again from there. And that's pretty much it. That's all you have to do to configure a layer. And then to draw it, it's as simple as just calling draw layer here, and it's that simple. And there's a couple of extra functions here for repositioning layers. Thanks for the resub, Doxter, appreciated. So let's show you that working. So this is the code that's going to run pretty much everything I've got so far. You can see if you ignore the layers, which is going to be the shared library section. Thanks for the follow, Pixel Dust Labs. The actual code to run this is quite small, and quite a large chunk of this is storing and copying palette data, and some temporary kind of scroll mechanics here, as well as floppy load stuff. So let me just stick the picture on. So I'm going to work on the right hand side. So I'll do most of my code on this side, and the left hand side will be for display. So I'll keep the layer config over here. Needless to say, the main function is literally just these draw. There's really nothing in this file except for some layer positioning, some scrolling, and I'll show you it running. I think most of you've probably already seen it if you've been on my Discord or Twitter today. If you haven't, I'll keep it running at the bottom. So when you compile, when you assemble, even what happens is the make file is run. Which is this one here, and this starts by passing the Sprite files. Is that loading? Yeah, it is. Let me show you the Sprite files as well. Oh, that's bright. So this is the Sprite file. I said it's not the right one. Hang on. This one. Oh, point. Yes. I'm thrown off completely by the sound thing. There you go. So if I just turn everything off in here and just enable things as we go along, so you can see a background here. There's one layer. This is completely static. You can just about make that out in the background. There's some clouds at the top. You can't really, I can't move my arrow over it, unfortunately, but you can see some clouds in the top lines that are these things here. So that's static, that doesn't move. That has a scroll factor of 0, as I said. You can see that in here. Scroll factor of 0 just means it doesn't move at all. Where's it gone? There it is. Then there's a background layer here. I don't know why there's a gap here, but you don't see it anyway. So you can see that that's got a scroll factor of 4, so it moves 4 times slower than the foreground. And then there's this layer, which is in the middle. Then this one, which is just before the foreground, you can see there. And then the foreground, which is the huge map. So the huge map is the one that scrolls to the end, all the way to the end and then repeats. But as it does so, this is basically tiled all the way across. So it allows us to have very small sections of parallax, which repeat all the way across, which is nice. And then the HUD, which goes on the top. Now, at the moment, the HUD is just a tile layer, but it probably wouldn't be that anyway when using it properly. I just wanted to demonstrate how it could be implemented as a layer. Follow the story, but Raiden is on hold. Raiden, yeah, I would like to do it, but again, I want to do something that doesn't require running after licenses. It's a painful thing to kind of try and get, and I really don't want to waste my time doing something for it to be shut down. Basically, I want to give the Mega65 a really good launch title that doesn't need us to go and chase licenses, doesn't need us to jump through the hoops that we would normally have to do. We don't have the money to buy licenses, so it's unlikely to be something that we can really do. Whereas a nice original title, well, it's a little bit harder to kind of do things like get artists and stuff for. Makes more sense in the long run. Thanks for the follow, by the way, the Mesh Potato. I missed that one. Rained on where you fire out umbrellas. Anyway, yeah, that's how it's built in Sprite. And what the build does is it runs a little node script, which takes all that data, does a bit of conversion. So the first thing it does is it splits this palette up into 16 color palette slices, so that everything in here just its colors exist in one slice. So that's quite an intense algorithm. It has to generate a new palette based on this palette. Thanks for the host, Andy. And so you can see that here. It tells you how many palettes palette. So it starts with actually it's 89. It hasn't really done. Oh, it doesn't do the change here. It tells you how many it begins with here, but you end up with a palette that's a little bit bigger. And I should probably output that data from here, but I don't. And then it gives you loads of information about each layer, which you can use to fill in the config over here. So I can see the background layer is 25 by 34, so I can fill that in here. Probably going to automate that at some point. Link this to this, so it doesn't have to do this. And yeah, and then it just generates all the tiles, removes all the duplicates, gives you some extra information, and then allows you to run the piece of code like this. So let me explain how it works, and Alex, because you can probably see the little raster bar at the bottom flickering there. So that's around about 32, between 32 and 40. I've been toying with it a little bit, and I've had to add some stuff into it. It's got a bit bigger, but it's between about 32 and 40 raster lines, and it doesn't get any more than that as long as you're only scrolling in the X direction. And the reason for that is quite simple. I'll explain that in a second when I go through how this is actually working. So we talked about raster rewrite buffer on a stream quite a long time ago now, probably before Christmas. Let me do it on the bottom of here, actually. Let's get rid of all of this. Don't need that anymore. So the raster rewrite buffer allows you to redraw over certain areas of the screen. So if we imagine a typical Commodore 64 drawing the letter A across the screen, it's going to draw like this until it gets to the end. Let's say this is the end of the screen here. Let's put a little marker here. It gets to this point, and then it stops. It's drawn an entire row, and it stops, and it goes on to the next row, and draws the next row. What the Mega65 allows you to do is it allows you to, at any point on here, is say, actually, I want you to stop drawing, and I want you to go back to the beginning, and I want you to draw more characters, but from the beginning here. So the data may look like this in memory for one screen row. So you can see this is all just one data in one line. But what you can tell it to do is you can say, okay, when you get to this point, go back to the beginning and start drawing. And even though I'm putting these on separate lines, these would be overlaid on top of each other. And so you can create multiple layers. And that's what we're doing here. So each one of these layers, as it's defined here, is just one of these sections. And so what we have is we have this width, and this tells us how wide a layer is. So the background is 21 characters wide. So we have, let's just put numbers in. Like that. So that's 21 characters. And then what happens is layer 2 starts, and this is how it's laid out in memory. So there's a little marker here. I'm going to make the marker as an @ symbol, like so. And then layer 2 begins. And then there's an @ symbol, and layer 3 begins. And each time it reaches its @ symbol, it tells it to go back to a position over here. And that position can be between 0 and 16 pixels. So I think what that sorry, I'm reading I was reading the chat at the same time. It can be between 0 and 15 pixels, sorry. And what that allows us to do is scroll any of these layers individually from each other. So what I'm doing is for the background, I have a layer here, and I set the background's X position to be something or other. And then I set the next one, and I set the position here. In fact, what I'm actually doing is, if we treat this as the foreground here, say my fine scroll position is 8. Okay, so remember, it can be anywhere between 0 and 15. Say my position is 8 here. What I do on this layer is I half that value based on its scroll value, but it's technically halving it. So my scroll is 4 here, and then on this one I half again. Scroll is 2 here. So what that does is it allows me to scroll each layer at a separate speed. Now, the problem with this is if you keep doing that, what happens eventually is um, when you reach the edges, it needs to redraw. So every time it reaches 16, because we can only go from 0 to 15, so it's in multiples of 16. So every time one layer reaches a multiple of 16, you have to redraw that layer. And that's what that flash at the bottom of the screen is. And the problem with this is if you keep going, let's say the fine value, it can go past 15, because technically it's a combination of a coarse value and a fine value. You can see now at this position, we have to redraw both this layer and this layer. And that's bad. So it's going to take twice as long. And even worse, if we get to 64, you now have to draw this layer and this layer and this layer. So now I have to draw all three layers. So what I do is based on the scroll factor, I add that to these values here. So whatever this value is, the scroll factor, I add it here. So the scroll factor for this one is 2. So it actually becomes 34. The scroll factor for this one is 3. So it actually becomes 19. And what that does is that means that no layer with a different scroll value will update at the same time as another one. And so that means that all 4 of our moving layers here. There's actually 6 layers being displayed. There's actually 7 layers being generated, but the 4 moving layers here will never update at the same time. So it's a really simple trick, but it's enough to if that's what you're talking about, Mythical Duck. Maybe you're talking about the spiral. Okay, so what we're going to do tonight is the sprite layer. So the sprite layer is another layer that sits in the middle in here, and much like these layers, it also let me shorten these layers down a little bit, right? So we imagine that's a background, that's a middle ground. Let's add a foreground in here, and then a hood. I'm going to do the hood with a H here. No, let's just do 4 in here. Okay, so we've got a background, we've got a middle ground, we've got a foreground, and we've got a heads-up display here. Let's make these all the same size. So what we want to do is we want to add sprites into this. Now, we can use hardware sprites, but the hardware sprites have exactly the same limits as the C64. You can only use 8 on a line. And to display more than 8 sprites, you need a multiplexing routine. And while this machine is definitely fast enough to do a multiplexer, it makes sense to use these software sprites all over the place. Are the same size as well? Not quite. So there's a few variations of the size. So you've got the standard size 24 by 21. All sprites can be any height you want them to be. There's a flag which allows you to set custom height for a sprite. So the same way you have Y expand, you have custom height. The custom height is shared across all sprites that have the same custom height. So a sprite can either be 21 pixels high or the custom height, whatever that is. And that custom height can be the entire height of the screen as well. Sprites are 24 pixels wide if they're normal sprites. That shrinks down to 6 if you're in full color mode. But you can then do super wide sprites as well, which then will up that to 16, I think. Yeah, 16. So you can have 6, 16, 24. I think you can have 64 as well with the super wide, depending on how many colors you've got. Sprites have X and Y flipping. No, they don't, unfortunately. That is something I would maybe like to see, actually. I might have a word with Paul about that. I don't know if he's on here at the moment, but if that is possible, that would be good, because one of the things you'll find is that memory runs out very quickly. Yeah, having a way to reflect those sprites would be good. It might be an easy addition. I don't know. I need to speak to Paul on that and make a note of that, actually. Just get my little booklet out. So the way our sprites are going to work is we're going to utilize this character system to do the same thing. Sprite flip. Let me write that down. So the mode I'm using is an extended character mode. So first of all, I'm using 16-bit character pointers, so you can store your font across the entire video RAM. You're not limited to a 16K bank like you are on the VIC-2. And secondly, these are 16 color, not 256 color characters. So when you're in extended character mode, your characters take up 64 bytes each. In full color mode, that's when you've got 256 colors per character. That character is 8 by 8 pixels, because 8 times 8 is 64, and you have 1 byte per pixel. In 16 color mode, you can double up the number of pixels you get out of each byte. So you actually get 2 bytes, 2 pixels per byte, or 4 bits per pixel. And that allows you to either store the character in 32 bytes, or what the Mega65 does is it allows you to store the character in 64 bytes, but now the character is double wide. So all our characters are 16 wide and 8 high. Which I can't really show you because I don't have an example of that being displayed. But all these characters that you see on the screen are 16 characters wide and 8 characters high. That's kind of nice for us because when it comes to sprites, we can create a 16 by 16 sprite just by stacking 2 of these on top of each other. Which just happens to also be the size of a tile in our map as well. But with 2 characters, 128 bytes, we can form a 16 by 16 sprite with 16 colors, which is pretty decent. So that's kind of what I'm aiming for this sprite system. And the way that's going to work is we insert a sprite layer in here, like so. But unlike the other layers, which just have this go-to symbol at the end telling it where to draw the next layer, a sprite layer has a go-to symbol before every single character. And what this allows us to do is position horizontally all the sprites on that layer. So that it doesn't matter if this layer is longer than other layers, because each one of these is going to be positioned separately. It's essentially like this. Each one is a separate layer. But I kind of count this as one single layer because it's kind of treated the same across the board. But each one of these is a 16 by 8 character that can be displayed anywhere horizontally across that row on the screen. And so by displaying the top half of a sprite on one row, and then on the next row displaying the bottom half of it here, we can display a sprite at any horizontal position on the screen. Now, there is one other problem with that. This doesn't give us any control over the Y position. So what the guys at Mega65 did is they introduced an offset for the data grabber, for the data fetch for this character. So as you probably know, the way the VIC works is every time it draws a single line of pixels on the screen, it goes and fetches the data that it needs to draw. So if you imagine a line of pixels looking like this in memory, let's do something like that. And we're drawing across the screen, and the screen's blank. And then we get to this point, and the raster rewrite buffer says, "Okay, you need to draw the top of this sprite." And it looks here, and it says, "Okay, this is our data in memory here. Let's do a couple of lines here, so I can demonstrate the effect." So this is on this line, so it goes, "Okay, 1110." 1011, and then it's drawn it, and it carries on drawing the rest of the line. That's one line of pixels on the screen. Then it draws the next line of pixels, and it goes, "Okay, now when we left off, we were here, so the next bit is here," and it draws like so, 10010111, and draws, and so on and so on, and it keeps doing this down the screen until this character is completely drawn. Something like this. Now, if we want to shift this, if we want to change the Y position of this, say we want to nudge it down a row, so there's a row of blanks here, all we have to do is have some blanks in memory before it, and tell the Vic to fetch from a slightly earlier position. And that's what they've done in the Mega65. They've allowed a system where I will show you the trying to think of a good set of sprites to show you, because I've already done this with some sprites. So look at Raiden. So basically what you need to do, did I do it in here? Oh, I did it at the bottom down here. Okay, it's fine. It's at the bottom of the map down here. So what you'll see is for each bullet, there is a gap between it. At the moment, the gap's got this pixel in it because this was just at the time I needed a way for it not to remove duplicate pixels. But you can see between each vertical strip, there's a space, there's a gap between it, and this allows us to display these at any vertical position as well. So we need to do a few things when we draw these sprites. First, we need to work out where they are horizontally on the screen and set our raster rewrite buffer pointer to point to that location. And then secondly, we need to work out where they are vertically on the screen. And what that means is if a 16 by 16 sprite is exactly aligned with the grid, then it will just be displayed like so over two rows. However, if it's shifted at even 1 pixel up or down, we now have to display it over 3 rows, because we need to show a portion of the top here, a portion of the top plus a portion of the middle here, and then a portion of the bottom here. So top and bottom here. And so we have to use 3 rows to do this. Cyberpunk Blade Runner port or cut down version. I kind of want to do I do want to do a kind of dystopian future style Greek tragedy. Well, not even Greek tragedy, just Greek hero story, which I talked about a bit in the Discord. That's what I really want to do, but getting an artist who can just do that stuff and wants to do that stuff and wants to do it for free or very little is very, very hard. But I would like to do that. I've actually been looking at some free assets today. I found a really nice asset pack. Let me see if I can find it. Hang on, I think I've got it on my desktop. Yeah, this one here. So this has got some fantasy characters in it, but they're really quite nice. And the guy who's done these, I've bought all these asset packs. There's quite a lot of stuff he's done. But I took most of his asset packs, and I've got all these characters plus loads of environments as well, which they fit into. I don't know if you can see that, but nice looking little sprites. They need adjusting because they're 64 by 64, so they would need adjusting down to like 32 by 32 or something. But could look pretty good, and it comes with a full set of routines like effects and jump effects and stuff. There's a high jump. Here it is. Big jump routines and stuff. So some really nice stuff in there. So at least for the kind of engine demo, that's what I'm going to be working with. I'm going to be doing some stuff on that. So, oh, no one got that. SP said it at the end after Tekken. Shame on you guys. Shame on you guys. Okay, so let's start taking a look at this. So what I want to do first of all is I just want to test that this sprite layer is working. So you see, unlike the other layers we give them a map piece to define the sprite layer, to define the layer. With the sprite area, what we do is we give it. Let me just make this the right size so I don't lose it. There we go. With the sprite layer, what we do is we just give it a size, and this is a size in characters. This is how many characters wide the sprite layer is. Now, because the sprite layer has a go-to has a next position for each single character that's displayed, each character is actually two characters. It's one which is the go-to marker. It tells it where to draw it, and the other one is the character. And so the number of characters you can display on a line, or number of sprites you can display on a line, is this number here divided by 2. So in this case here, we've got 48 sprites per line. I'll show you why this is a limitation. If I try and up it to 98 sprites per line and run this, you'll see what I mean. This is what happens when the pixel clock runs out of time. But in all honesty, 98 sprites on a line is more than anybody's ever going to need. 48 is overkill, but there's a reason why the number is high, and not lower, and that's because in order for us to display sprites that move along the Y position, sometimes you will need to display one sprite twice in the same line to, like I said, to get that top middle section. So while it's technically 48 sprites per line, it's actually 24 of the full size sprites, and 24 is plenty. Plenty of sprites per line. And the number of sprites that we display is only limited by our processing power. And because we don't have to sort the sprites, that's not as big as a problem as it would be for a multiplexer. So 256, 128, 256 sprites overall is easily achievable. More than enough. But there, you can see what happens when we reach the pixel clock. Things don't start rendering properly. Some layers get missed out. You can see the HUD isn't displaying properly there. The position of certain things is kind of wrong, and the colors are all wrong as well. So that's what happens if we hit the pixel limit. You can hit the pixel limit just once you reach a certain character count. This is why I'm using the 16 color mode rather than the 256 color mode. So in 256 color mode, the screen is 40 characters wide, but in 16, let me just restart so we can display something proper. In 16 color mode, the screen is 20 characters wide. I add one extra character on because it's the width of a tile, just so we can do the scrolling left and right, kind of like switching down to 38 from 48 columns in on the C64, but going the other way, increasing the size rather than reducing it. And so you use half as many characters to display a single layer wide. So in effect, it gives you twice as much screen layers to pile on top by using this mode. And you still have 512 colors that you can use across the whole screen. It's just you can only use 16 in a single 16 by 8 character block. But as you can see, I mean, 16 colors is absolutely fine. It's probably what most Amiga games were using. In fact, I think 16 colors was probably more common for sprites than it was for background bit plane stuff. I think it was 8 colors. I don't know. Someone will have to correct me on that. I don't know what the usual amount of colors. I know. I think it was 16 as well, actually, because I think Turrican 2 has 16 colors for the background. So yeah, 16, but that's 16 over the entire map, whereas this is 16 in a block. 16 in a block, and then you can change that between blocks as well. So you basically have 32 palettes of 16 that you can pick from. So we're going to split it into 2 halves. We're going to use 16 palettes of 16 for the main map, which you're seeing now, and we're going to use 16 palettes of 16 for the sprites. It depends how many bit planes you assign to background, 2 to 32. Okay. 16 colors because the Atari ST was limited and ports between Amiga and SY were common. Yeah, that kind of makes sense. Turrican 2 definitely is 16 because I was messing with the art from that recently, and it definitely is just 16 colors. Which made me realize as I was kind of messing around with it in scrolls and stuff that it's overkill to use full color 256 color mode for it. So right, anyway. Oh, thanks for the host Prayer 7 as well. I may have said that, I don't know, but anyway, I'll thank you again anyway. Before we start, I just want to remind people we do have the competition running. for the spiral, which I'm sure you guys are absolutely crazy about at the moment. The winner will be announced on Saturday. I'm going to take entries right up to midnight. And at midnight, I'll announce the winner, and we'll go over the top 3 or 4 or so. I don't want to spend too long on it, but we will go over a couple. Jerome tells SIDS are always quite quiet, aren't they? I think it's all the samples. And I had to go for about a day, and then I just never got around to picking the code up again. Also, the Amiga Blitter was slow. The fewer bit planes, the smoother things got. Yeah, and the other thing as well, the other advantage of doing it this way, not using bit planes, is say we've got some water or some waterfalls or something. It's a real easy task to animate that across the whole map without having to re-blit the map. So what they would probably do on the Amiga is have a character set or a tile set, which they would animate in memory somewhere, and then when it was blitted to the screen, it would show up animated on the screen, but you would still have to blit it to the screen. But what you can do here very easily is you can pause the map scrolling, so there's no update happening on the screen, and then use DMA to animate something very very quickly, and it will update across the entire screen. So definitely has its advantages doing it this way. But anyway, yeah, the competition is going to be announced on Saturday. We'll go through the top between 3 and 5. I don't know. It depends how long they take, how different they are, and such. We'll go through the top entries. The winner will get the Mega65 Nexus 4 board, which is this one. Nexus 4. It's not the DDR one. This one. It's just a normal board. I have pre-flashed the SD card with the files needed to run it. I am in the process of waiting on a new tank for my printer. The tank bust, so I have to get a new tank. It's coming tomorrow, and then I will print out a new case for it as well, because there's no JTAG connector hole here over here. Sorry. So where my thumb, where my finger is here, there's a USB connector behind that. I've already got the prize for next month. So I've got the Nexus A7. This is the DDR board. I believe this is the 100T. It better had be. I haven't actually checked. See, it doesn't actually say on the. Okay, I should probably check that at some point. I believe it is the 100T. I paid for the 100T anyway, so in fact, I'm going to check that now. I don't know what the yeah, that's what I need to check if it is the DDR one or not. It's just it says both on the back, you see, so that's why I'm worried, and there doesn't seem to be any other markings on here which would tell me otherwise. So this is the 100T. Okay, cool. So this is the DDR model. And this is what we'll be giving away next month. As also, 5 Sprites has kindly donated one of these as well, so there will be an additional board that I'll be giving away as well at some point. Yeah, I got the 100T sticker on it. So. Anyway, that's what we'll be giving away at the weekend. We'll be giving away one of them at the weekend. The next one will be based on another challenge, which I'm not entirely sure what it's going to be yet, but it's not going to be as stressful as the spiral. I guarantee you that much. Okay, so what I want to do is test this sprite layer. So to do that, what we're going to do is we're just going to insert some data into this layer just to make sure that it's appearing. The easiest way to do that is when it's generated. So this layers file is horrible. I will tell you that now. I've gone over this so many times and refactored it and changed things up and down here and there. Stuff's commented out everywhere. So, but I don't intend this to be something that people need to mess with. It's supposed to be a kind of it's supposed to be a kind of import and forget sort of thing. Flexible kind of dynamically generated code. There's a lot of code like this That's a good example. Stuff like this, which will generate tables based on certain properties, and then there's lots of code like this in here, unrolled, but with values pulled from the config. And then other things here with like if statements in it. So we've got conditional stuff in here as well. I wish my RTA 7 would work. It's just 129, but too underpowered. I don't think the RT would. I don't know though. Maybe it would, because RT is a different brand, isn't it? There's the Nexus and there's the RT. But I think you said yours was the A35. I think. Yeah, A735. I don't think that's enough to do it. I don't know though. You could always try it out. You could always just download the manual. Download the Mega65 manual. It's in the Mega65 channel in my Discord. Just go and download that in there. It tells you how to set it up. It's really quite simple. You may need to build it yourself somehow. I don't exactly know how the VHDL works and what the difference is between the different boards, but I know there's slightly different bit streams for different boards. So okay, so in the middle of all this, we do have init screen RAM, and what init screen RAM does is it sets up the data that goes, the default data that goes into these layers. So with a normal layer, so when it's not a sprite layer, we set the go-to position, which is the scroll position. So the go-to position is changing, as you can see on here, between 0 and 15 for each of the layers, and that's what causes the scroll of the screen. So much like the hardware scroll in the C64, we're using this go-to X as a kind of hardware scroll to just scroll between one tile width. And then when it's scrolled more than one tile, it just redraws the entire screen, that entire layer again. Specky core would be sufficient. Saw the Mega65 update video today. Something about latest ROM version can only be supplied with hardware due to licensing. Oh right, that's the. I think I misunderstood that video. Then I need to watch it again, because I think the licensing, they were talking about games at that point. Maybe I might be wrong. But there are some the community's hard at work, um, piecing together the ROMs from various locations. I'm going to turn the music to ever so slightly down. The C65 ROMs from various locations, so we've got newer versions than we thought we had before. There's newer versions of the C65 ROM than we thought there was before, which is kind of cool. They're having to rebuild some of it, and there's also, alongside that, there's the open ROMs, which is I forget the name of the people working on that now, but there's another team of people who are working on creating a completely license-free version of the ROMs. So taking all the vectors, the locations of where these things are that run, or all the different routines that run, and the where they are, and the variables and where they're stored, and replacing the actual code with their own versions of the code. Which is not an easy task, because how many different ways are there to do some very small things? There's not that many. So so that must be quite interesting. I'm not sure how they're doing on that. But that's feral child. That's it. Yeah, thank you. I knew somebody was working on it. But yeah, I imagine that the first step is to try and find the ones that you can save the most space on, and then use that by refactoring and writing them differently, and then use that space to change things around. So there's a billion ways to any. Yeah, but it becomes infinitely more difficult when you've got to make everything still launch at the same memory location. set the same variables, and it's kind of crazy what they're doing. But it's the only way they can get around the licensing is by providing their own. Thanks for the follow, Da Chicken 007, and thanks for the host as well, Sinlo. Appreciated. So yeah, this is a normal layer. So it's got the go-to position, which sets our horizontal scroll position on the left side, basically where to begin drawing the layer, and then it draws the layer here. So you can see it's just a quick loop which goes through the width of the screen. So this is one of the properties in our layer config in here. You see width here. So it just prints that many characters across the screen, and it's just filling them in as we go. Again, it's 16-bit character definition, so each character takes 2 bytes up. And that's a normal layer. This is a sprite layer, so you can see it's a little bit different. So we still have the go to X, but it's inside the loop. So now for every single character, for every single byte in the sprite layer, we've got a start X and then a character as well. So the loop goes through with divided by 2. Hey Stoker, welcome. Stop all LDX and LDY to avoid copyright issues. Yeah, and it's tricky. It's tricky. I don't know what the limits are on whether or not code has been deemed copied or not, but I imagine they're trying to do things in very different ways. I mean, it's hard. There comes a point when you can't do anything in a completely different way. So, yeah. I move the scroll window down a bit to hide the flash. I can turn the flashing off. That's probably the easiest way. Hurts the eyeballs. Let me turn that off then. Just to go back to that a little bit as well, the reason why the Mega65 is better at scrolling in the X than it is in the Y is because we can set these layers to be drawn at any X position. So we have individual kind of X repositioning of the layers, and it doesn't affect the redraw. So we can stagger the redraws like I described before, where each layer is drawn on its own in that frame. No frame draws all the layers at the same time. This only ever draws one layer at a time. We don't have that in the Y position. So in the Y position, we have to use actual hardware scrolling registers to scroll it, and that scrolls the entire screen up and down. So this has 2 problems. Firstly, it means that the parallax can't really do vertical parallax without using a kind of sprite layer like we're about to create, and that's going to be very heavy on memory and very heavy on processing. So you kind of have to lock the vertical parallax to do it like that. And secondly, that means that whenever because they're all locked, whenever a layer needs to be redrawn, they all need to be redrawn. So when you start scrolling in the Y direction, what you end up with is every single layer redrawing when you go left and right, up and down. Sorry. Where would you find the current challenge details? In the Discord. So if you join the Discord, if someone can drop a link in chat, and go to monthly giveaway challenge. There's a challenge in there. You've got till Saturday, around about midnight on Saturday. I'm going to be streaming on Saturday from about 9:30 again, and then round about midnight I will announce the winner. I'm going to take a quick break now. When I come back, we'll dig into this because I've been talking for an hour and we've not really done any code yet. So I'm going to take a quick break. I'm going to leave you with my awesome Be Right Back screen, which will hopefully send everyone a little bit crazy. And I shall be back in 2 or 3 minutes, guys. Be right back. I am back. Who got that? There's some pretty fast people in here. I don't know who that was. Okay, right. Let's take a look at doing this layer then. So The easiest way to start with is to change the fill character here. So one of the properties I've allowed for is fill characters. So if I just go and set so it's called sprites. I'm going to put it in the right place. So if I set layer prop sprites and then set fill char and then set a character number. Now I'm going to pick a character number up in the HUD area because then we're going to actually see some stuff. So I don't know what character numbers those are, so I'm going to have to go and find them manually. So just bear with me a second. So I want to develop kind of some tools around this library as well, so you can see character numbers for things. At the moment, I have no way of knowing what these character numbers are. Luckily, I know how things are formatted, so it's easy for me to find those details here. So I'm looking in the HUD, and I can see the HUD is telling me the tile that's at 836C. Where are our tiles? Our tiles are at 5800, so 36C is the tile. I try and do as much pre-calculation as possible in the 360. That actually seems quite low, but okay, whatever. Oops, wrong. Oh, damn it. Oh, I guess it's not that low. Fair enough. 36C would be. Oh, that's this. Oh, God damn it, that's the blanks. All right. So yeah, I do need to create some stuff so that you can see something other than these blanks all the time. 8B18. There we go. That'll do. 8B18. So B18. This reminds me of Arcanoid. It's Arcanoid. There we go. 84C8. So the upper byte of these character dates is the color, is the palette selection. So I'm not too bothered about that at the moment. So I'm just going to go with the low. So 4C8. So if I change the fill to 4C8, oops. Hopefully now that layer should fill with sprites at that position. Now the only problem is the star text by default is also going to be in a weird place. It's going to be off the screen in that direction. So we're going to set this to be somewhere in the middle of the screen. I don't think that's quite the middle. I think it's probably just off to one side. But hopefully now when I compile this, we should see a line of characters down the middle. And that will show us that sprite layer is actually working, and then we can start looking at the routines we need to display those things. But it's worth verifying before we get into that. Okay, it's not drawn exactly what I thought it was going to draw. It's drawn something completely different. Oh, because of the character offsets. Let me draw 8C8 like that. There we go. Because we also have this character offset here, so we need to apply that to any characters that we display. But we can see it's drawn something down the middle of the screen. It has also drawn something down the left, so I need to make sure why. Have a look to see why that's happening and make sure that it's not something broken there. And there we go. So it's displaying something from the HUD. It's actually it looks like it's displaying the S and the C from the HUD. But obviously it's displaying it with the wrong font, so it looks a bit weird. But we do have that extra line of characters down that one side, so I'd like to figure out why that's happening when we're just using startx of this value here. It should only display. So look, we've got. Oh, what's that? We've got to go to there. I'm not sure what that's about. Oops, just make that a little bit bigger. The 911210. I can't remember why I'm using that, but yeah, I try and keep up with them a little bit. I think I'm 1 or 2 behind. Good night, Sean. Oh man, you're cycling to it's freezing out there at the moment as well. Yeah, I couldn't tell you why I'm using that one. I think I just upgraded it when I had the chance. It's pretty easy to do as well. I mean, it's on your SD card anyway. I might. That's a good point actually. I do need to update the board here with that as well. Um, so whoever gets this will probably get my code running as well. So I may share this with whoever gets it, but I will have this running anyway. Thank you, Digital Cluster, for the follow. Appreciated. Okay, so this is what's happening when it's drawing sprites. It's doing this, but then it's drawing one here. Let's just set these all to the same value here. So let's just set these to zeros, because I want to see what happens if I tell it to just draw down one side. What happens if I ignore the start X? Yeah, good night, Sean. Sleep well, dude. All the amateur traders are dumping stuff. Yeah, I've been watching that today. It's been quite funny. I think it's kind of hilarious. Did that actually load? Yeah, it did, didn't it? Oh, because I typed an 8 there. That's why. All right. Uh, yeah, it took a bit of a crash today, but I think it's because everybody's been selling off. So, um, I mean, I think the stock needs to drop from it's at 200 and something now. It needs to drop down to like $10 or something for the hedge funds not to lose any money, but tomorrow. But it's not going to happen. So, what type of stock? No, GameStop. So the brick and mortar store. Reddit have been buying the stock to basically short squeeze hedge fund hedge fund kind of traders. Um, Look it up. I don't want to go into what shorting is. It take me ages to explain. I won't be the best person to explain it. But it basically involves uh, borrowing stocks and then paying back them stocks later when they're cheaper. But Reddit has screwed them over and basically made them lose billions. In fact, I think a couple of them went bankrupt as well. Yeah, Electronics Boutique here. Yeah. Okay, so that did display at that position. Okay, let's move it back over to the middle again. We still have this one down the side. So that's what I'm worried about is why is that one down the side? Is it always going to be there? Can we move it, or are we stuck with that one down that side? And if so, why are we stuck with that one down that side? Because we technically shouldn't be, but we do seem to be. And I have no idea why that one is there. So there's a go to X here at 80. There's a go to X here. Okay, why is that one there? That's weird. Let's have a look at the go to. So this is the color RAM area. This is what actually tells us to go to a certain area, which is this one here. And there's a go to X at the end here, but this is the very last thing it does. Maybe it's to do with this one here. Let me try changing that. Yeah, shorting stocks is, in my opinion, it's a kind of shitty way to make money from trading. And it's kind of always been reserved for the big boys in the investment markets. And now, like, Reddit's come along and started doing it. They hate, yeah, this is gambling. You're basically trying to make money off a company going down in value. But the Reddit's come along and screwed them over, and now they don't like it because Reddit has basically banked a couple of hedge funds. And I don't want to buy my. Sure. Yeah. Okay, so that hasn't affected that, but I don't know. What I don't understand is where this other column is coming from here. So let's break this down. Let's change this layer to only use two two characters. So this will be a go-to character and a fill character, and we can see if it still draws that. We should just still get one line of sprites down the middle. If we don't and we get a second one, then there's something weird going on here. We need to fix that. Oh, so if there is any if there is anything in here that looks unusual, let me know and I'll try and explain it as we go through. Okay, so yes, there's an issue here in that this go-to layer is being set to the beginning of the screen over there. So that's the first issue here, that this layer is being displayed automatically at that side of the screen, regardless of what I set here in this value here. Now to work out why that's happening, because it's just on this one. It doesn't seem to matter what I put in here. The first layer is always going to appear there, which makes me think this layer is... No, it should be fine, because this one... Previous layer, okay. Yeah, see, I don't see any reason why. So we've got normal layer, it has go to sprites, go to and then load of characters. Sprite layer has a go to and a character repeated multiple times. And this is one. Yeah, okay. I'm just trying to make sure that all the bytes match up. Maybe there's a missing byte somewhere, but I don't see it. Width, yes. 1, 2, 3. Sorry, 1, 2, and then width times 2. Okay, and then in here we've got 1, 2, width times 2. Yep. 1, 2. Hmm. 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 Just on that first one. That's the annoying thing. Just on that first one. No matter what I put in here, it's not going to appear in the right place. Now. Wait a minute. Is this because... This is because... I know why this is. So I have a bug, and what the bug is, I have this function here, reposition layer and set layer scrolls. So what these functions are doing is they're taking the scroll position of the layers and they're propagating it down to the other layers. So the way this works is you just set your control layer, and in our case, our control layer is layer 4, it's this one here, and that is our foreground layer here. So you're 1, 2, 3, 0, 1, 2, 3, 4. You see foreground layer here. This is our control layer. So what we do is we scroll this one around and everything else gets adjusted at the same point. But what that means is the layers have their scroll position set, and the scroll position is the go-to marker for each layer. So the go-to marker is here. You can see when I initialize it. So as I was saying, in the screen RAM, you have a go-to, and they have 21 characters that go across the screen. So what we're doing is we're shifting this go-to marker to make the screen scroll around. The sprite layer has a scroll position of a scroll factor of 0, so that means it doesn't shift with the screen, and you can see that it's static like the background, the far background, the red background, or the score at the top. So it doesn't move. But what it does is it does gets its scrolls set back to 0 all the time, because that's what a non-scrolling layer does. It sets its scroll to 0. So we need to make sure that that's ignored for sprites. So that's quite easy to do. That's in this reposition layers, which has got a load of conditional code in it here. And we can see that this code is not run if the layer is sprites. This isn't run if the layer is sprites. But it is being run. That's interesting. Okay. Here we go. Number of layers here. Okay. Yeah. So this is the one we need to change here. Oh wait, hang on. No, set layer X offset. No, this is just setting it. I think. Hang on. Yeah, we need to ignore it if it's not set in here. Okay, so we're going to need some more information here. So what I do have is I have a couple of where is it? Is it that one? No, it is. Shit, where have I put it now? It offsets layer with row starts. Maybe it's this one. Yeah, it is. There we go. Layer scroll factor. Okay, this isn't enough though. I don't think the layer scroll factor is enough. What we actually need is sprite layer. And actually we can change this to be a constant. So we have this create sprite layer here. So all I'm going to do is I'm going to create, we've got control layer number here. So I'm going to put sprite layer number. Default that to 0 as well. Move these up to here as well. So these are assemble time variables, which means we don't have to worry about kind of looking them up in memory addresses. They can be immediate mode references, but they will be set by these things here. So basically, we're going to set the sprite layer number to be equal to basically the last layer that we've just inserted in. Which is going to be done on a create sprite layer. So that means now when we go down here on this bit here, we can do what would it be? It would be compare Y to sprite layer number, and if it is the same, then we jump to skip, which is going to be here. Get rid of all that. Don't need that anymore. Also, I found out that these so a few of the instructions are 1 clock long, mostly the single byte instructions. However, that push and pull is not. So what I'm going to do is I'm going to use self mod to put these back, and also I'm going to start using this where I can, because self mod is going to be a lot more useful. So I'm going to keep using this method to put labels in the middle of the code. It's something I've kind of avoided doing on the mainstream, partly because I wasn't used to it at first, but also because I think it makes it a little bit trickier for newcomers to understand what's going on. If they see the +1, they can kind of question why it's +1, and they can maybe look and say, okay, they can maybe understand the machine code a bit more. This isn't quite as easy to read, so I've kind of avoided doing it. But I'm trying to keep this kind of neat, so I've been using this throughout here. in quite a few places for this self mod stuff. So I'm going to be doing that a little bit more often as we go through. Just in case you wonder why I'm doing that and not doing my normal method. I'll probably forget sometimes and use the old method, but I'll do my best to remember that. Okay, so I think that should prevent that side being, because now if it's a sprite layer, it's not going to do any layer repositioning because it isn't a normal layer. So this should be hopefully in the middle again. Excellent, cool. Okay, so we're ready to start building a sprite system now. Buy high, sell low. Oh no. All right, cool. I think what I'm going to do for the sprite system, I'm going to leave this code in. So this is a temporary kind of loop that I've set up. You can see it's drawing 6 layers every frame, or the draw layer is intelligent. It won't draw if it doesn't need to. So it will only redraw the layer if it needs to. Otherwise, it will just position things. I probably do need to move this into something macro like this. But this is very much generic, not generic. This is very much a bespoke code just to scroll this map and to demonstrate how you would scroll. But this is all you would probably need to write as custom code to have a map scroll like this with this engine. But I'm going to make another file here. I'm going to call it RRB sprites because that's what they are. And I want to distinguish the difference between RRB sprites and normal sprites. Because I will use normal sprites, but I'm not going to use them in the way you would think I'm going to use them. I'm going to use them for things like the HUD and stuff. So at the moment, the HUD is just another text layer over the top, but it's a bit of a waste. It really doesn't need to be to be utilized in another layer like that. So I'm going to remove that and use actual sprites for that. And then for the rest of the in-game sprites, I'm going to use the software versions, these RRB sprites. So I'm going to create an init function. So these sprites, they still need a clear routine. I'm just going to call it clear actually rather than clear sprites. And the reason they need a clear routine is because what they need to be able to do is the sprites need to be able to move around, right? And we're not blitting them into a scene and pulling them out. So clearing isn't a matter of kind of um, you know removing the pixels and restoring the background. It's not such a slow operation. The clear routine is literally just resetting this data that we've just set up in the init. Where is it? It's just resetting this data, so it's just going through that row of screen and just clearing it. And by clearing it, we only have to actually move these markers to be off screen. So the go-to markers. It's only every other character we need to set. This one can remain as it is. It really doesn't matter. And then what we'll do is for each row of the screen, we'll keep a counter, and that counter will say where the next sprite goes, where it goes in the memory. And that counter will basically point to a row, point to a memory address. Uh, thanks for the bits your was taken. Appreciated very, very much. Cheers. Good night, Quadrasil. And good night, Dr. Miz, as well. Take care, man. Yeah, so we'll keep a record of whenever we draw a sprite. So we'll go through our list of sprites, and for each sprite in the list, we'll say, okay, which row does it need to be drawn on? Then we go and have a look at that row's index, and we say, okay, that row hasn't anything on it yet, so we'll paste it in the first place in that row. and then we'll advance the marker so the next one gets drawn in the next position, and so on and so on. When you reach the limit, 48 sprites per line, you stop drawing. Thanks for the follow as well, Your was taken, appreciated. So all Clear is doing is basically resetting these start X's so that nothing appears on the screen. It can appear off the screen, it really doesn't matter. It doesn't matter if it gets processed. The whole row has to be processed. So it's just clearing these and resetting the indexes. And then we have draw sprites. And what draw sprites is going to do is it's going to go again through our list of sprites. And as I say, it's going to work out for each sprite which row does it live on. It's going to plot it into that row, advance any indexes on that row so the next one gets drawn in the right place, and so on. And it's just going to go through the entire sprite list like that. And you'll notice at no point do we need to sort any of this. Nothing needs to be sorted. Everything is just piled into rows as and when it's found. This has a couple of advantages over a multiplexer. One, it means we automatically have sprite layering priority. So the sprites that are drawn first, whichever way we go through the list of sprites, whichever ones are drawn first will appear at the back, and the ones that are drawn last will appear at the front. So that's kind of nice. So I'm going to propose that we go backwards through the list of sprites. So that sprites with a higher number will appear at the back, and sprites with a lower number will appear at the front, with sprite 0 being the one that's on top of everything. That means we can kind of define some player sprites in the first couple of sprites, and everything else kind of fits in the back there. And of course, it means we don't have to do the sorting as well, like I say. So that's kind of nice. So we need an init, we need a clear, we need a draw. The init is I don't know what the init is going to do at the moment. I think it's probably just going to set up some basic properties in here. So I'm going to have a data array in here. This data is going to be our sprite data. And we're going to have a label in here as well, which is going to be our max RRB sprites. So I'm going to set it to 256 for now. I think that's kind of plenty. I think it will probably be too many. I don't think we need that many. I think 128 is probably enough. Bear in mind this is RRB sprites. Actually, yes. So the sprite would be 16 by 16. So 256 RRB sprites is actually 512 characters displayed on the screen, because each sprite consists of a 16 by 8 and then a 16 by 8. Rather uncomfortable in my chair. So yeah, we have to be careful how many we try and push here. We're not going to hit a pixel clock limit. We've already set that limit. All that's going to happen is once we reach 48 characters on any line, you were just going to stop taking any lines, stop drawing anything on that line. So it's to say it works exactly like a normal sprite system would work. Once you reach the limit, it just stops displaying things. But hopefully with a limit of 48, that should be pretty hard to hit, I think. So what we're going to need, we're going to need an X position. And I'm going to split this into high and low as well. We're going to need a Y position. I might as well split this into high and low as well, even though, actually, no, we don't need, it's just like the C64, we actually don't need high and low. So we'll just go for Y pos here. Okay, I mean, that's the basics, but we're also going to need a color. Now, the color is the slice of the palette to use. So remember what I said before, that the each character is 16 by 8 pixels, and in that 16 by 8 pixel block, you can use any of the 16 colors in a slice of a palette of 256 colors. So this color will be which numbered slice it will be. This is the value that's going to get put into color RAM. So we do need to put something into color RAM as well. But that's fine. And again, clear and draw are going to do that for us. So we need a color. We also need the pointer as well. So this is going to be a value which points to a 64-byte block of memory somewhere. So this is going to be very similar to how the characters work. It's a 16-bit value. It's going to just point to a random block of, well, not a random block, but a specific block of memory somewhere. There will be probably some helper functions around this. I'm thinking what there will be. There will be something like get pointer from sprite number. Yeah, like a macro or something, sprite num or something. It's a bit long. That it's looking like a Java function, isn't it? And what this will do, in fact, I'll make it a macro now, and we can fill it in later. What this will do is with C64, you define a sprite by its sprite number, right? So you say this is sprite 0, this is sprite 1, this is sprite 2, and internally what happens is those are converted to pointers, which then I use to look at certain memory addresses. With the memory addresses being in 24-bit memory space and well, 16-bit memory space actually, but actually no, they're in 24-bit memories. No, they're not. Hang on. No, the pointers will be pointers like this, but we need to apply offsets to them. I think that's the difference here. So there will be a little bit of difference here. So for instance, our sprites are going to be 16 by 16. But in order to display that sprite, we need a 16 by 8 character, another 16 by 8 character to show the bottom, and then a blank space underneath it. So that character is actually three sprites, three characters, which means there's 3 pointers. So the pointer for each of them would be 0, 1, and 2. So if you were to point at sprite 0, your pointer, your sprite number is 0, your pointer is 0. But if your sprite number is 1, then your pointer is actually at 3, so it increases in 3s. So that's what this is going to do. Let me just put a marker in here to say what that is. So pointer equals sprite times 3. Because otherwise it's just going to get really confusing. If we don't have this macro in, it's just going to be a little bit confusing to pick a sprite number out. So having to multiply by 3 all the time to get the actual pointer is going to be a nightmare. So okay, okay, pretty simple. We can add more to this later. I think this is kind of enough for now. To be honest, the important things that I'm going to do today are going to be these. Color I need to look up because we're going to use the alternate palette for these. Oh god, I've got really stiff back and achy stuff. Really not good. Okay, so let's fill these up with these values. I'm going to have an enabled as pointer is 0. If the pointer is 0, then it's disabled because nobody's ever going to use pointer 0 because that would be the first 64 bytes of 4 bytes of 0 page. Wait, so it's going to make graphics in there. Hey, Thalamus. What I'm possibly going to do at some point, I think I tried to display this before, is get, was it that one? Oh, was it this one? Get these little characters in. I think they're really nice. I bought some asset packs. I need to reduce the colors down to 16. And well, in fact, I'll show you how I do that now. It's really simple. So go into here, reduce the palette down to 16, turn off alpha. Okay, so that's the palette down to 16 colors. And then trim. And then I also need to reduce the size as well. This is the bit that's going to need a little bit of work because I need to work out the best way of doing this scale algorithm. So I might need to touch these up because it looks a little bit blurry, but they still look pretty decent though. You can see those characters look really nice. So I'm thinking of having something like that running around in it. So yeah, exactly. This is the thing. I don't have an artist to do the stuff I want to do, and I'm really just trying to prototype the engine right now. So I want to get all the things like sprites and collision and stuff in. So yeah, it makes sense to do this. I am strongly considering using this engine to do another marathon stream at some point, and do Luna using a background like this. You imagine this background and this tile set, but Luna. It would be really cool, I think. So that might be something that happens in the. Oh God, no, Wolf. Who recommended this? But yeah, I may do that in the coming weeks or months. Just need to find the time and the motivation to do it. So, uh, but I think it would work really well on this, and it'd be a quick win game as well, and it would demonstrate some of the functionality of this engine. So, is the background also from? Yeah, the background's from an asset pack as well. I got There's a really good asset pack on Itch at the moment. That's got a combination of um uh like different backgrounds and tiles and stuff. I forget the name of it. It's hey, Epic Neon Ninja Monkey, what are you working on today? I'm working on Mega65 game engine. So Mayhem in Megaland. Mayhem would work really well on this machine. Actually, it would look incredible because you'd have super fast scrolling, really nice parallax, very high resolution as well. If you wanted it to, it would look amazing. Yeah, make it so, Thalamus. Anyway, let's crack on with this. So yeah, I'm just working on Mega65 engine at the moment. I shall make some calls. That would be a winner. That would be it would be incredibly easy to add into this engine as well. This engine is set up for it. Uh, it would be kind of cool. It would need some really nice detail um, to do it justice. Anyway, with your talent, uh, well, I like this version of Monty on the Run. This is cool. Yeah, this is really cool. Yeah, Luna 65 when he's saying, can you imagine Luna flying along on this? It would look incredible. I could do it in a night as well. Once I got the sprite engine in and stuff, it'd be really easy to do in a night. Could reuse most of the code as well. It would just be the display code would have to be changed, but most of the logic and even the sprite and control logic could stay pretty much the same. Um, yeah, the Y scroll difficulty is a problem. It's not to say you can't Y scroll. You definitely can, and um, I have got kind of the ability to do that with this engine. It's just that when you scroll in the Y, you get that syncing problem. And because you don't have fine Y control over individual layers, you have to then draw them as these kind of rewritten raster layers, which kind of opens up a whole can of worms with memory usage and stuff. So definitely can be done. I'm not saying it can't be done, but I'm just not. I'm not kind of looking into doing that right now. I want to get the best out of this as quickly as possible, and this is definitely the easiest way to do it. Um, I mean, if you limit the number of layers you have, like if you just do one layer, then absolutely you can scroll around as fast as you want pretty quickly. The moment you start adding multiple layers of parallax in, it gets more complicated to scroll in all directions. Okay, so we're filling all these up, and what we want to do is for every sprite that we have a pointer that is non-zero, we're going to display it in this list here. So first of all, let's remove our dummy data from here. Where is it? Where is our setting here? In fact, I can just comment them out. The default for sprites is that the layers will be set way off to the right, so you don't see them. Yeah, if anybody does want to redraw the Lunar Witch in a 16 by 16 sprite with 16 colors, please go for it. I'm sure it can be done quite nicely. 16 colors, one being the transparency, so actually 15 colors. But any 15 colors you want, literally. You're not limited. The palette is like the full 24-bit palette. Well, it's technically it's 23-bit because there's slightly less reds, but I mean you won't notice the difference. My God, where do you get some of these ideas for songs? Oh my God. Oh, I'm gonna. Sorry, I have to skip this. I can't concentrate with that one. That's actually the worst. Okay, so Luna is hard. Yes. Yeah, Bug. I mean, that guy knows how to hurt your ears. Okay, so in it, I don't think I need to do anything in it yet. So I'm just going to do RTS. Let's start by doing the clear. So the clear needs to go through each one of these layers and clear it out. So first thing I'm going to do is I'm going to make sure that this raster rewrite buffer has a quick access to each row. So in here, where is it? I think it's in, where is it? Where is it? Where is it? I know it's here somewhere. Here we go. Layer. Is it layer lookups? Hang on. Row starts. Here we go. Screaming cows, ideological scream. Yes. So this is our row starts, but this is the row start for um the entire row. So this is the start of each screen row, but at layer 0. We don't want that. We want this plus a layer offset, which we have here. So I'm going to do that by, this is always going to get imported as part of this layers system. That ensures that any reliance on these settings in here is carried over into here. It's going to get imported directly after this layer config here. So we're in screen already. So I'm just going to import RRB sprites here. So what that means is up here we can have sprite row. I'll just call it sprite rows. And this will be basically, it will be the row offset plus, so it's this basically, plus the layer offset, which is my God, do I not actually store that value? Okay. Hang on, layer config get get the layer level, then upgrade. Okay. So that's fine. I can store the layer offset. So I'm just going to create a var here to store these values in so I can easily look them up. As I said, none of this is supposed to be exposed to the user anyway. So I'm just going to create a list like so. I think that's how you do lists, yeah. And then I should just be able to add. Wait, hang on, layer config. Yeah, I should just be able to add those in. Okay, so whenever I add a value here, I also need to the layer offsets add exactly the same value. +2. think that's right. I think that's right. We'll see in a second when I do this. Do I need to do a val there? I think I might need to do an eval to add it in. Yes, I do need to do an eval. Okay. Okay, so then up here, that means I can do all of this. Like so, plus V layer offsets. Get I. Okay. Let me move that over here, then it's a bit easier to see. I've got to remember that that's displayed on that side. So what this is doing, this is creating a table of screen rows. So the beginning of each row of the screen, but just for the sprite layer. So in fact, what I'm going to do with the init, I am going to call the init. I'm going to call it at the end of our main init. Sorry, not main init, our layers init in here, which is this bit here. So after all of this is done, I'm going to call rb sprites.init, which is going to allow us to kind of have any cell we need in here. I'm going to, for now, I'm just going to test something. So what I'm going to do is I'm going to go through this list here, and I'm going to grab a location out of here, and we're going to put a value into that location. Now, the first location is going to be, actually, yeah, we'll do it for each row. So what we'll do, hang on, let me just start writing and then do it. So let's compare X with screen row count. There we go. Right, so the first thing we need to do is we're going to need to double that value because it's in words. So we might want to change that actually to high and low. In fact, yeah, let's change that to high and low because it's going to make it a bit easier. So let's do lows first. Sprite row, low. Could do high low fill here as well, which I might do at some point, but that's fine for now. Okay, so now we don't need to change that. Now we also have somewhere in here a routine called reset screen RAM pointer. So we need to call that first. That's going to set a pointer up in 0 page for us. And that's basically going to set the upper 2 bytes. So the screen RAM pointer is 4 bytes. This is going to set it's going to set all 4 bytes, but then we can replace the bottom 2 with the values from this table. So we're going to load sprite row low X, and we're going to store that at screen RAM. Oh, God damn it, what's it called? Screen RAM. Okay, it's not. So that goes in the low byte. And then this is the high, which goes in the byte 1. And now we're now pointing to the beginning of that particular screen row. So now what I'm going to do is going to set Z to 0. And then this is going to allow us to actually draw some values into here. So what we're going to do is we're going to start by we're going to make these go all the way across the screen. So we're just testing that our screen rows are correct here. So what I'm going to do is I'm going to transfer X to the accumulator, and I'm going to times it by, let's do 8. There we go. And then we're going to store that at screen RAM pointer, comma Z. So this is a 32-bit indexing mode, the double brackets. The standard is actually square brackets, but as I've mentioned before, the square brackets have a unique meaning in Kick Assembler. as actual kind of evaluation parentheses. So you can't really use them without breaking Kick Assembler. So Jesper did the add-on for this as add-on for the fork of Kick Assembler for Mega65 implemented as double brackets. No way, I thought I recognized that. So there we go. We're storing whatever the X position is, whatever row it is, into the X position. The row number times 8 into the X position. Then we'll increase set. Then we're going to load 0 because we don't want the high byte of the screen position, like so. So that's our go-to position. Now we need to store the character there. So we did have a character in here. I'm going to just use this same character. So 8C8. Again, this is just for testing. So that's what we're going to try and put in. So, oops. So we need to load the accumulator with C8. Doesn't quite work on the C64 list, as it's a shame. It's a nice piece of music there. And there we go. So that's actually drawing the 4 bytes that we need to draw something in that sprite row. So hopefully now if I start this, instead of that line down the middle, we should get a diagonal kind of sweep of characters across the screen. If this has worked. I feel like I'm getting an error somewhere there because it's not loading. Oh, can't define the macro in there. Okay, so this macro needs to be outside of here, but that's fine. Logical screen width. Why is that not? Oh, because that's in layers. Oh, damn it. Wait, please tell me that's shared, or else I have to move it out somewhere. Layers. I think that's probably all right. Let's have a look. That's fine because that's a config. Okay. Really? Oh, it's also in there. Okay. I'm going to move that out. Actually, no, I'll keep it in there because it's only used for this. Again, this is one of these systems that's going to be hidden. I'm trying to make all this kind of messy stuff. God damn it, reset. That's also a layers thing. To be kind of hidden to the user under normal circumstances. That's ZP, ZP. So I had a bug yesterday. I was messing around with it for ages, and I couldn't work out why some of my layers weren't displaying properly. And what I'd completely forgotten, variable not okay. Do I have to keep that outside then? Maybe I have to keep it outside. Yeah, what I didn't realize was my floppy routine was moving the 0 page to a different location. And it was completely screwing up all my 0 page stuff. And it took me ages to figure it out because I just wasn't used to moving the 0 page. I'd completely forgotten that I moved it inside the floppy loading code. So at the moment I implemented loading stuff from floppy. That's what this is down here actually. This was the value I was getting when it should have been like 0000000 or something. That's why. Okay, so I've moved that up to there. So my sprites in here can move that. Yeah. So the reason I want to test these rows out is because they're going to make life a lot easier when we go to. Seriously, index out bound at 0. Oh wait, is that because? Oh shit. Okay. Hang on. I need to think about this. That should actually be imported at the bottom. I know it's weird, but I think it should be. I think that's what's breaking it. No, it's still failing. Next out of bound 7. Okay, well, it's not failing in the same way now. 7. How many layers do I have? I don't have 7, do I? It's 1, 2, 3, 4, 5, 6, 7. But this is number 6, so 7. Yeah, is wrong. V layers get offset. Oh, I know why. Because this should be sprite layer number. We'll get there in the end. Boom, there we go. Whew. Hey, Fig. Fig, Proton. I called you Fig. Yeah, I'm not seeing any sprites across the screen though. Okay, so at this kind of point, it's good to start looking into actual memory and seeing where these things are. So first thing I need to do is work out where the screen is. So the screen is at 50,000, and our layer offsets should be described in here somewhere. Here we go. Sprite Layer at position 5, so that's this one here. Which is 222, which I believe is in. Well, why have I described it in freaking decimals? Okay. Oh, and also we've only got 2 sprites. Let's put all the sprites back. Let's change this to actually display in hex instead. Make this a bit easier. And then we can go and have a look at that layer and see where things are. Okay. So layer offsets, where's that? It's written up here somewhere. So much of this output is actually useful, which is why I need to change this to hex so it's more useful then. Okay. So you can't see it because it's there, but here we go. Let's just oops. God, I keep doing that. Keep moving that layer. So you see here the layer offsets. So this is the layer we're interested in. Its offset is DE, and our layer config says that the screen is at 50,000. So what I do here now is I open up M65 Connect. I can do this on the machine as well, but it's pretty easy to do it on here. And then M50,000, but DE. So if I do 50,000 DE, and there we go. I can see the data for this row. So this row is saying it's at 000, which is correct. It should be displaying 08C8, but I'm not seeing that on the screen. So that's interesting. Thanks for the follow. I missed the name. Let me just grab the name. Juan Coperu. Thank you for the follow. Welcome to the stream. Okay. So I can't tell why that's not in the right place, but well, I would have thought we'd have seen something here with that, but apparently not. So let me just check, because looking at this, we actually have. Oh, hang on. I think it's offset slightly. So I think it should be Okay, I think it's 2 bytes too early, so I think it needs to be 2 bytes later. So that's fine. It can go in here. Just need to add 2 to these. Just put these on new lines. Actually, hopefully this works on new lines. It should do. It does in JavaScript. We'll soon find out, I guess. Yeah. No, it doesn't work. Okay. Oh, God damn it. Time to turn word wrap on, I think. And then it does it automatically. I'll get a widescreen. My screen is widescreen. Problem is I have to have the text up super high. Like normally my text is like that big. But you guys won't be able to read that, so and I'm not going to force you to read that, so that would just be cruel. Yeah, there we go. And now we've got it moving across the screen properly. So yeah, so you can see we can set horizontal positions really easy like this. Okay, so let's start by getting some horizontal position stuff done. So they're 8 by 8 sprites. No, they're 16 by 8, and we the system that draws them in 16 by 8 blocks. The tiles are 16 by 8 basically, or the characters are 16 by 8. But the system I'm using is going to stack 2 of them together to make 16 by 16 sprites. So what I'm calling an RRB sprite will be a 16 by 16 pixel block, consisting of either 2 or 3 of these characters, depending on the Y shifting. Red, blue. It stands for raster rewrite buffer, if anybody's wondering why I keep calling it that. Because that's what it's using to draw them. So the Mega65, yeah, it does obey the C64's conventions, but it's also got a load of its own modes as well. So there's an 8 by 8 character mode, which you can have either as high res, so same as C64 high res, multicolor, so exactly the same as C64 multicolor with the double wide pixels. But then you can have full color mode, which allows you to create a palette of 256 colors out of 24 million or whatever it is, 24, 23 bits. No, it's about 8 million, I think. Create a palette 256 colors out of 8 million colors, and then use any of those inside that character. So that's what full color mode is. Basically 200. It's called full color mode, but it's 256 colors. I mean, you can only have 64 in an 8 by 8 block anyway. But then there's a 16-bit mode. 16 color mode, which is 4 bits per pixel, which doubles the width. So instead of doubling the width of the pixels, you double the width of the character instead, which I think is a much nicer approach. So it's essentially doing what multicolor mode was doing, which is using the same amount of space to define more colors, but doing it by, instead of expanding the pixels to be twice as wide, you expand the character itself to be twice as wide. So it's why we get 16 by 8. It also makes the raster rewrite buffer really efficient because you don't have to draw as many characters per row. It does, however, make tiles less efficient. Yeah, that background layer is split into 5 different tile maps in Sprite in here. Let me just open it up. So it's actually 6 tile maps because the HUD is currently a tile map, but it won't be eventually. But each one of these layers is a tile map, and the script generates a map based on these, and then the raster rewrite buffer composites them all on top of each other, each with its individual X position, built out of these tiles. So it's kind of Yeah, that's what this export is doing. All this text down here underneath the under here. That's what all this is doing. It's an exporter for Sprite, which takes the project file from here, and automatically kind of calculates a new palette where everything is kind of in the right places, and splits it up into tiles and removes duplicate tiles and stuff like that. So um, it's quite good, and it means you can use a standard tool like this as well. And this map is generated using LDTK. So I'm going to show you that. If anybody's not used this before, this is the best thing since sliced bread when it comes to map design, which allows you to uh, create a set of rules, which you can then use to draw a map. So let me just hide, or let me delete that layer. Are we on the right layer? Yeah, there we go. Right. So these rules are basically you use them to draw stuff. So the rules look like this. There's tons and tons of rules. You can set them however you want, and it's an auto tiler. So now if I try and draw some ground, I'll get a bridge because it's just one thick. If I do it too thick, it becomes ground. It puts stuff on top and below and stuff. So you can really quickly draw maps. Um, with little to no artistic skill, really, just a tile map. It's kind of, yeah, it's auto tiling. And I just spent a bit of time um, generating the rules for this to be kind of neat, and allow me to do some cool stuff. So like I've got water tiles, which let's just get rid of that a second. So if I put water in here, but then if I do yeah, so I can create, it's pretty neat. It's really powerful. It's written by the guys that did Dead Cell, or by one of the coders that did Dead Cell. Uh, move the yeah, sorry. Let's just move it across. There you go. Because you're not really seeing anything there, but yeah, it's written by the guys the guy, the coder behind Dead Cells. Um, it's a really amazing tool. Definitely recommend it to anybody who's doing any kind of tile mapping. Uh, use this because it's super powerful. It does take a little while to set the rules up, but once you get them set up, it's really easy to kind of generate stuff, and you can see how quickly this is kind of turning into an actual map. So that'd make Creature 3 really easy. The follow messages are obscured as well. I need to find a better way to pop that window up when I compile instead of other times. Yeah, but yeah, it's a brilliant level editor, and it's free as well, and it updates so often as well. Another update. Um, it's always coming with cool stuff, and it's really easy to work with as well. That's the cool thing. You're just sitting down with it for maybe half an hour or so, and I got the hang of building the rules. And now I pretty much know how to use the map inside of it. But it also has world maps in it as well. So you can create a world out of things. So you can kind of like add levels in. So here's a world here. There we go. I'm going to add a new level up here. You can add tons of levels, join them together. Um, but it's also got entities as well, so you can add enemies, power ups, things like that, and paths and things. And um, yeah, super easy to use. You know, I had so much fun with it when I was doing it. I spent about a day, about an hour, sorry, learning the kind of ropes of it. It took about half an hour to get the hang of it to a decent enough level. And then the rest was really just kind of playing around with it. And like a day later, I've just been knocking out levels like really quickly, and I had all these. I mean, my rule list is massive. These are all my rules. I've got rules for slopes and water beds and decor and ladders and all sorts. There's quite a lot, and they're all custom. Um, Yeah, and you can import multiple tile sets and stuff. But the cool thing with this is it has the reason why I use this. It not only does it output a nice JSON file, so you've got a JSON file you can work with. It also allows you to export each individual layer as a PNG file. So that's what I've been. I don't want to save. That's what I've been doing to build this. I've just been importing the layers into Sprite from there as a PNG. So. Um, but yeah, it's an incredible level. It's the best level editor I've ever used. It's so easy to use and feels so natural as well to do things. But anyway, I mean, I just use it as a temporary kind of for a temporary kind of thing for now. I probably will use it in the final design, but because it is so good. But for now, it was just a really quick way to knock out a half decent looking level. So anyway, right, back to the code. Actually, I'm going to take a quick break, guys. I need to go to the toilet and get another cider. So I shall leave you with the quiz spiral, and I'm going to come back. We'll finish off the. Well, I don't think we'll finish it off, but we'll get as much as we can get done in 45 minutes. So I'll be right back, guys. Be right back. Okay, I am back. Ooh, did we have the music to that not long ago, or did we have the? I think we had a different platform, didn't we, or something at some point? I'm sure we've had that recently today. Old school coders submitted his game, Scramble game. Awesome. Oh god, I can't wait to play all these games. I have a feeling that's going to take me a couple of weeks to do, to be honest, because I've not played any of them yet. I don't want to. I don't want to see them. I don't want to spoil it for me when I look at them later. So I've been avoiding them. Fresh, fair kind of judgment on them all. Okay. So now what we've got this init function which is actually filling out the rows with some data. So this is temporary, but we can use this now to test the clear function. So what we're going to do is we're going to clear each row, and pretty much it's the same routine as this. But now what we need to do is instead of stopping here, we need to keep going until we've done a set amount, and that amount is the. Oh, do we even? I bet we don't even record that value, do we? Anywhere. No, we don't. All right. So we need another value here, which I'm going to call sprites per line. So this sprites per line value is going to be calculated based on the width of the sprite layer here. So we set the width here, but we also need to set this value to be width divided by 2. It also needs to be floored because we don't want any 0.5s here or anything. It shouldn't be. It should always be an even number here, but let's do that anyway. And then that means in here we can start doing things, probably some of this backwards. We can't really do. Well, actually, maybe we could. No. We'll go forwards through the row, but we'll count. We'll count backwards, like so. There we go. I'll call this outer loop. I'm gonna be consistent with the casing. Why not? There you go. So why am I counting down here? So I'm going to indent this again so we can see. So the reason I'm counting down is because now what I need to do is I need to actually set these positions to all be 8010. So it's going to be 80 on this one. Sorry, 0180, like that. And then this will be increase Z, and this will be increase Z. But instead of doing increase Z all the time here, what I'm going to do instead, I'm going to look up how fast a certain instruction that I can use instead is going to be. So in order to do this, I'm going to add some timing markers in here. So I'm going to put this back in here, and then I'm going to call. This is just going to give me an idea of roughly how long this routine takes to go through every screen row, clearing that should be that, clearing the row out. Now the other thing is as well, at the moment, this is what this is doing. This is in fact, I have to do it this way because Z is going to start at 0. Oh, hang on, that should be load accumulated with 80, and that should be 0 here, and that should be here. Yeah, there we go. Because what it's doing, what it's going to do is Z is going to start at 0, and it's going to use that offset to increment this one, and then leave 2 gaps. Sprites per line would therefore need to be less than 64 for this to work, because if the entire row takes more than 128 bytes, then Z is going to loop round and this is going to break, because we're using 4 each time. So sprites per line times 4 needs to be less than 256, which it kind of is. And yes, okay, so this will work, but I'm going to look at a different way of doing this, which might be better. So first of all, let's just see how long this takes. So let's get a rough idea from the line at the bottom. Okay, forgot to do that. Notice that we don't need to set the sprite that we're displaying. We just need to set the position, because we don't really care about the what it's displaying, because it's being displayed off screen. It's being displayed at 0180. And so you can see that's how long it's taken. That's not too bad for a clear routine, considering it's doing 256 sprites. I think we probably would use a few less than that, though. Actually, no. This is screen rows times sprites per line. Okay, so sprites per line I said was 48. See, 48 is still plenty. Let me see what happens if I bring it down. Or let's have a look if I can optimize the function first. So this is the slow bit here. So what I want to try is instead of increasing this Z, I'm going to do this instead. Actually, don't think it's going to be any quicker at all, because now what we're doing is we're increasing the. This is like an inc command. But instead of incrementing a single byte, it increments a word at a location. So we're incrementing the bottom 2 bytes of this 32-bit location. I think this is probably going to be quite a bit slower. I'd be surprised if it wasn't. Let's take a look. Oh, we don't have the thing on. There we go. Nobody said anything. God, you're all too busy gambling and stuff. Oh yeah, that's really, really slow. Okay, so we definitely need to use the increase Z. Now, what I could do is I could put 81 in here, get rid of this, and move this to here. I think that would probably optimize it quite a lot, actually. Okay, that's a little bit less than it was before. Still feel like it could be a bit less though. So the other method we could use here as well is to use a DMA function to do this instead, which would actually make this almost instant. I'm kind of very tempted to do that actually, because I want the clear to be pretty quick, so I don't really want to be messing around too much. All right, I'm going to have a look at DMA. So let me just grab. Oh, where did I do some DMA? I did it in here, I think. So let me just check through code in here. Dma Animations. Here we go. Oh, that's right. I had some macros. I created some macros to do this. Which means I've still got them in. Dma copy job. Dma. Okay, copy that will do. Let me just copy this block out. We'll go and stick this in. So DMA, the C65 and the Mega65 have what's called a DMA magic chip in it. And what that does is it allows you to very quickly copy things from one location and actually mix things together as well. So I'm going to use it to clear the sprite area, which means it needs to be a fill. So I just need to go and have a look at the C65 documentation. DMA magic, because I can't remember what the fill operation is. Is it this one? Yeah, okay. So one of the documents you'll probably use a lot if you're using Mega65 is this text file from Zimmers. It has a lot of stuff about how the Commodore 65 works, and some of the stuff in here is the same on the Mega 65. So this is the DMA magic, and so what I'm looking for here is the operation. So fill is 1-1. Okay, so yeah, 1-1. Okay, so that's 3. So this is chaining. This is not chaining. So chain allows you to put multiple things in a row, multiple DMAs in a row. We just want to do one DMA, and we want it to be fill and last request. Okay. So I think with fill, we can define a source. We don't need it to go backwards. So the size of the copy. So the size of the copy is sprites per line times 4, because we need to copy 4 times as many bytes. So that's how big we're going. We need the header for this as well. So there is a header piece of information, which is this one here, source bank, destination bank, and then we need the 00 on the end. Okay. So the DMA task is basically just a list of bytes which define how we copy from one area to another. The first byte defines the format. There's 2 different types of DMA, and then we define a source bank and a destination bank. So the options start with a byte which defines the option, and then the source bank is the upper memory address of it. So that the last the nibbles 2, 3, 4, 5, and 6 basically of it. We're copying from wherever this is going to be. I think it's going to be a fill area here. I think I need to look at how the fills work actually. If I can just fill, or if I have to copy from one area to another. But the destination, the source and the destination are both going to be 0 because we're copying into low memory. So our bank 0 goes from 0, 0, 0, oops, 0, 0 to F, F. And this value here is these two numbers here. So it's always going to be 0, 0 and whatever and 0, 0. So those two stay the same. I need to work out how the fill works. I don't think I've done a fill. I was hoping there was like a pattern fill that we can do, but I don't think it is actually. I think it's like a perform next command, no interruption. Hang on. Mod direction. Is it the mod maybe? Okay, and this is our destination here. So I'm going to put sorry, source. And this is our destination. I don't need that last byte. This is the bank again here. So we know this is in the screen. So I'm going to actually grab it like this. Screen base 16. There we go. It's going to give us that upper bank area. I don't know what this is going to be yet, so I need to fill that in a second. I'm just going to put 0 for now. And this is our destination and source. I'm just going to leave them as FF. So I need to figure out how to do fills, which is a bit annoying because I've never done a fill before, so this is going to be interesting. Let me check the manual. It doesn't really tell me a lot, unfortunately, for DMA. Probably an area that needs filling out a little bit. Transparent value, no. Where's the fill value? Okay, I have no idea. So thankfully, there are some things dotted around the internet with this information in it. Let's try and find one. This is the biggest problem that anybody will find when you're working on the C65 is that the information is quite rare. There isn't a lot of it out there, so you have to. I mean, thankfully we've got the Discord group and stuff, but finding the information you need can be really difficult sometimes. I don't know what the fill byte is. Let me check grading because I know I've done some stuff on these projects in varying kind of levels of where is it going to be? Let's look for DNA. And I know some of this is copied from various locals. See, like this one's copied, and I can see lots and lots of extra information here. So, copy size of copy starting at bank. Yeah, see, I don't know what he's going to fill it with. I have a feeling that one of these values here will be the fill value. Well, let's try it. I think this is going to be the fill value. So I think if I put 81 here, it's going to fill this entire area with that. We just need to set the destination. So, and then we need to call that function. So let's give it a try, see what happens. So what we're doing at the moment is we're saying, okay, draw this many, sprites per line across this thing, and we're taking screen RAM pointer here. So if I grab listen, let me see about I've drawn a witch for you. Oh, seriously? Oh, Stoker, you're a star, you really are. Oh man, that looks awesome. Oh man, that looks so good. Oh, it looks. I need to get it in Sprite because it looks bad on there. Hang on. Copy image. Gremlins. Man, looks so cool. I think it's using JPEG compression there, isn't it? So it's kind of it's messing it up slightly. But yeah, that looks awesome. Is that 16 by 16 as well? How many? Or is it bigger than that? It might be bigger than you need. Yeah, so I need to get it down to 16 by 16 if possible. I mean, I can always utilize more sprites using this system, but yeah, I mean that's really cool. It gives me something nice to start with. I think that's all I need really. Is once I get the art for this game, we can do a stream based on that. So how big is it? So it's about 32 by 32 roughly. So, but I mean, yeah, that's just gonna look. Yeah, that's awesome. Cool. Damn, you're a good artist, Stoker. If you want to do character art for my game, please feel free. Desperate for an artist, but I realize it's a big time investment for most people. Most people don't have the time to do it, unfortunately. So it's fine. I'll get one in the end. Don't worry. Right. So that thin red bar at the bottom, that is what we're trying to beat by using DMA. So I'm going to keep both methods in here, and we'll just comment one out and switch it out like that. So dest, is it destination? Yeah, dest 0. Okay. And then to start a DMA job, you need to set a few values. And those values are oh, seriously, if you can do that, I would absolutely oh man, you would be my savior. You honestly would be my savior. And the fact that you like mythology, then Greek mythology as well, then that would be awesome. But yeah, have a think about it because it is. I mean, it would be quite a time investment. I wouldn't expect anybody to just take that on quite easily. So, good night, Digital Stefan. Thanks for joining the stream. And I'm sure I could sort you out with one of these or something. So you've actually got some way of kind of to running it as well. Because I'm building these. I'm building up a collection of these now. Okay. Where are we at? Yeah. Okay. So the DMA. So the DMA needs it needs this thing here, which is to just trigger the DMA. So there's a few lines of code here, but hopefully this whole thing is still much smaller than. Oops. How did that open? Okay. Still much smaller than in terms of cycles to what's happening down here. Oops, there we go. So you can see the red line at the bottom. that's the current non-DMA way of doing the clear. Let's try it with the DMA. Hopefully this works and I haven't made a mess of things. I might have messed something up somewhere, but I think it's probably correct. It's down to whether or not this is right here. I think it might be right. I don't know. Well, I mean, it's done something, but I don't think it's quite done the right thing. So, but you can see how much thinner that line is. That line is super, super thin now. So I'd be happy to use this method. The only thing we use in DMA is it limits what you can do with mod music as well. So, grew up on Ray Harryhausen films. I don't know what they are. I need to, because if they are about Greek mythology and stuff, I really want to watch those. Oh, okay. Did he do the oh shit, what was the oh wow, yeah, I've seen some of this stuff before, definitely. Yeah, stop anime. That's freaking awesome, yeah. Yeah, I might have to look through them. But Jason and the Argonauts was the one I remember the most for those sort of things. I don't know if he was involved in those, but it was definitely the same sort of stop motion as well. I remember the skeleton fight scared the living daylights out of me back in the day. Yeah, it was really cool, but I was only young when I watched it. I was like 8 or 9 or something like that, and the skeletons scared the living crap out of me because they looked so freaking real. uh, yeah, of course, now we look at it and we can, with modern CGI and stuff, we're kind of spoiled. But modern CGI, it's an art form in its own sense, but I think it's overused. Whereas this kind of stop motion stuff, this was real art. I mean, to blend that in with kind of like motion pictures back then was incredible. The stuff they could do. Anyway, okay, so fill. I'm not sure if this is actually filling the right thing. It seems to be filling the screen. Let's just change the size of the copy down. We're getting some flickering stuff, and we're not seeing all those things disappear. Argonauts was him as well. Yeah, I thought so because it's definitely that same style. It's very cool. Yeah, but yeah, I kind of want to do. I want to do that kind of thing, but with a modern twist. So imagining if Perseus was, I don't know, a millennial now, but was still a monster hunter, was still kind of his job was to be a monster hunter, and he could work for the Olympus Corporation. There's loads of ways you can bring the Greek myths forward into the modern era and still keep the stories the same. And then that gives you like lots of opportunity for do you see the demo screen Frankenstein play a demo with skeletons who's going to be a myth type thing? Oh, no, I didn't actually. Oh wait, did I? Wait, I might have seen this. I think. Oh yes, it's spooky. Percy Jackson with guns. So, God damn it! Now I need to look up Percy Jackson. The name rings a bell, but I don't remember. Uh, oh, okay. And they've got a thing called the Olympians. All right. Okay, cool. That looks way cooler than Harry Potter. Gotta say, sorry, but it does. Oh, okay, cool. Yeah, I just like the idea of it, of like the gods being almost like, yeah, corporations, but like bosses of big corporations, and like the monsters being the guardians of some secrets or something in these corporations and stuff. I don't know. I've not kind of fully fleshed out the idea in my head. I was just kind of spitballing some ideas a while back. And that's what I came up with. I don't think this is working, this fill properly, because it doesn't seem to be filling. I'm not sure what it's doing. It's kind of messing with the wrong areas here. Destination, I would have thought screen RAM. So it wouldn't be storing it here. It should be storing it into here. Oh, that's because of that. There we go. So if this works, then we can reduce this down a little bit more. I think that should be times 4. There we go. Yeah, that's exactly, that's the kind of thing I'm thinking. Kind of steampunky, cyberpunky, just that kind of dystopian future. Even if it's steampunk, would work really well. Actually, I think probably more so than a more kind of sci-fi view of it. There we go. That's perfect. And see, now we've reduced that clear down to a quarter of the time, probably more actually, probably more like 6 or 7 to the time it really was before. Yeah, steampunk would work quite well, I think. So you've got because then you open yourself up to quite cool looking. I think steampunk tech always looks cooler than the equivalent sci-fi, the traditional sci-fi tech. So you imagine kind of even the outfits. Think of a steampunk outfit, and then think of compare. I'm trying to think of a typical steampunk thing now. It's steampunk game, but if you compare the traditional views of steampunk with, say, cyberpunk, right? Cyberpunk, the outfits are just kind of like all neon, and everything's kind of a bit bright and thing. Where steampunk just looks cool. You've got all like these brass kind of fittings and kind of leather. Chaos Engine, yeah, perfect example. Yeah, I like that idea. Let me know if you let me know if you'd be up for it, Stoke. Because if you are, I will introduce you to someone else that I'm going to be hopefully working with on this, and we can discuss it in a chat. So it would be kind of cool. I can tell you a little bit more about it in private message, about the kind of plans for it, and then I can speak with this other guy and hopefully get some ideas on the go for it. Actually, is he around now? I think he is actually. He's not. No. All right. I was hoping he might be in the chat watching this, but yeah, yeah. Let's have a chat because that'd be kind of cool. Okay, so that's working. So what I want to do then, in that case, I'm gonna leave this as DMA because I think it's nice and quick and I like it. I'm gonna reduce this down to this and this. We don't even need the 0 page setup, which is being set up here. We don't need that in this bit here. We're just using DMA here. I think we can probably get away with not setting these two as well. I think we only need to set this last one here. I think if we set all these here, put a note on here. So prep DMA vector, but not D705 trigger yet, because the DMA triggers as soon as you execute this store here. So as soon as you store the low byte of the DMA data, so this is just a pointer to this DMA data here. As soon as you set that, the DMA job executes, and basically the code freezes at this point until that job's finished. But that job will copy at I think it's 20 megabytes per second or something like that. It's quite a lot. It's quite quick anyway. Um, So hopefully that will reduce it even more. So hopefully that line is just going to get a tiny bit thin. Probably barely notice it, but I think it might get like one line thinner here, or it may break horribly because of the way the DMA is working here. Soon see. Okay. I mean, it may have got a line thinner, but I can't tell. But this is about as fast as it's going to get, I think. Oh, we could make this a little bit quicker. We could do screen cap -1. Yeah, like so, and then so that's a little bit quicker again. Still, we do need to set these each time. But there you go. So what that's doing now is it's very quickly moving everything off screen. So that's actually going through. How many screen rows is that doing? I forget how many it's doing there. Am I running the original or the patch? No. This is 911210. Hey AD, hope you're doing well. Listen. All right. Warlock just likes typing listen, I think. Yeah, using 911210. I believe so. No, hang on, let me tell on the boot screen. Yeah, 911210. Okay. Yeah, so normally I wouldn't want to use DMA too much because there is using the mod player that will trigger DMA every couple of kind of cycles. I can't remember what it is. It's like 11 kilohertz. So whatever it would need to play samples at that rate. So by just doing small jobs like this, so this job is not going to be. I mean, this is copying like 100 bytes at a time. Actually, it's copying. What's our sprite per row? Sprites per line 48. So it's doing just under 200 bytes at a time. Didn't someone have a question about the Mega65 they wanted clarified? Not sure. I was going to ask about the DMA, but that seems to be working now. So, well, I made a guess, and it seems to be the right guess. So I don't mind using the DMA for the clear because it's only going to happen in a very brief window right at the bottom of the screen. It happens in very small 200 byte segments. So even though it's copying probably round about, I want to say 6,000 bytes. For no, maybe not 6,000. Maybe about 5,000 bytes. It's doing it in 200 byte segments, so it's not doing a lot. So the combo closes on Saturday midnight. Will you be doing some dissecting, explaining the code? Yes, I will. So what I'm going to do, I'm going to end the stream in a minute anyway. So let's talk a little bit about the competition. I should leave the program running. Yeah. So move my microphone out of the way. So what I will be doing, we'll be doing some normal code as usual. I want to go through. I think we're out of bugs now, or mostly out of bugs. So I'll probably do some level organizing and stuff ready for testing. Oh, we do need to add an intro text scroller and a game complete kind of screen. So maybe we'll try and find some fitting that in. But we will be around about midnight or just before midnight, I will close the entries to the competition to win the Mega65 um, Nexus 4 board, and the case for it as well. So I'm giving the case away with it as well as an SD card with all the files on it that you need, and a VGA cable, supply VGA and a power supply, VGA cable and a power supply. The only thing you will need is a USB keyboard, because I'm not going to ship those because they're just a pain in the ass. But yes, we'll announce the winner at midnight. I will probably take a 5-minute break just to sort through the entries in case there's some last minute entries, and then I'll do like a rundown. Um, I'll do like a top 5 rundown or something, and then once the winner's announced, we'll go through each entry and kind of take a look at it. Probably do like the top 5 entries or something, unless there's any that stand out. I'll try and have a quick look through some of them. If there's any that stand out for the way that they work, then I'll talk through them as well. It's going to be difficult because I'm going to have to figure them out. But yeah. Oh, good night, Stoker. Yes, please do. That'd be really cool because I've been scratching my head over how to find an artist. So if you are up for doing that, you're an excellent artist. I'd love to have you on board doing it, and we can sort something out so that you can test out the game yourself as well and play it and stuff. So we'll figure it out anyway. So, but yeah, please do contact me when you get time. Was it about XY sprite flipping? Yes, possibly. I need to speak to Paul. I don't think AD can do anything about that directly. At least I don't think you can AD DBM. I don't know if you can, but I'm just going to call you AD because that's easier. Mm. But yeah, it'd be good if we could somehow implement sprite flipping, even if it's just X flip. I mean, maybe it's in there. Maybe it's in there, and I don't know. But is Stoker actually? Yeah, Reese Clathworthy. Yeah, Jack Cathworthy. Is it Cathworthy? I can't remember his last name. It's something like that. Yeah, yeah, really good artist. I mean, his work on the C64 Stoker game is just incredible. The stuff he's managed to make, that sprite is unbelievable. So if he's willing to, and he sounds like he's really into his Greek myths as well, so it's kind of a perfect match, really. If he's he's definitely good at animation. We've seen that with the C64 stuff. He's good at detailed drawings. I mean, that witch he drew in no time looked really good. So yeah, I mean, if I can get him on board and I can get this engine up and running pretty soon, which I think I will. I mean, it's coming on. It's slow progress, but it's coming on. Then I think we can make a decent game, and the Mega65 will have hopefully a freaking awesome first game to begin with. A kind of steampunk story of Perseus the Monster Hunter just sounds awesome. You'd even just call it Perseus Monster Hunter. It's got a good ring to it. All right, I think I'm going to call it a night there then, guys. Sorry we didn't get too much code done. I hope you've learned a little bit of something about how this engine works. I'm going to continue to do little bits of this on and off stream in between work and other commitments I've got. So while I will be building a lot of this on stream, I'm not going to do it exclusively on stream. So we'll be doing a little, it'll advance a little bit further. So hopefully next time you see it, we should have proper sprites in there. For the A7, you need to look for the latest official Commodore. It can be found in the web. Okay, we can share to dev kit owners. Yes. Okay. Yeah. You can find it online from some well-known sources. I don't think you can even tell people where it is. I think they have to kind of find it themselves. I don't think you can publicly announce where to get them. Um, That's a good point, actually. Am I guess I'm not allowed to include it on this either, am I? I guess I have to supply it with that bit missing, maybe, or I don't know. I don't know how that works. Um, um, I'm sure it will be fine, but I will find out because I may have to just tell people how to do this sort of thing. So, all right, cool. Let's find someone to raid. So next week is going to be a normal week. Going to do a Game Boy. I'm going to do who's on Chalks on this raid Chalk. Going to do Game Boy. I'm going to do Jesus Christ, wrong one. Going to do Game Boy on Tuesday. Going to do Checkanoid on Thursday. Saturday we'll do the game. And I don't know what maybe we start shifting Saturday over to Mega65 as well, because we are closing in on the end of the Pick and Mix project. So all right, let's start a raid on Chalk. Did Pick and Mix get completed? It's very, very close. Yeah, it's very, very close. We need to drop the levels in, need to make a game complete screen, and that's roughly about it. So thanks, ADTB. That's good, because I don't know. I think, yeah, because it's a present. I guess it really doesn't count, but we shall see. All right, take care, guys. Thanks for joining me on the stream. Hope you've enjoyed a bit of Mega65. We'll be doing a little bit more as soon as I can find space in the schedule, and I'll see you all on Saturday for Spiral Fun. Take care and enjoy Chalk.